Hi everyone, this is Mohammed Saif Shaban, an application engineer at CES. We are the authorized reseller of MATLAB in the Middle East, and today we are going to present to you this presentation about low-code to no-code programming in MATLAB. Uh, we will talk more about it in a minute. The agenda for today's presentation is what is low code, and then we are going to show you a demo that we are going to build a machine learning model in MATLAB to predict a response variable. And then we're going to share some resources related to MATLAB after that. And if we have time, we're going to show you how to create your own live task. And you're going to know what is a live task in a minute as well. If we don't have time for that, I'm going to make sure to create some content on that on our and post it on our YouTube channel. So make sure to subscribe to our YouTube channel. We have a lot of technical content there. Also, if you can follow us on LinkedIn to get notified about future webinars. So what is low-code? Low-code tools are tools in MATLAB that will enable you to achieve results and get results without coding or with minimal coding. One of the benefits is that it requires no long learning process. It has a shallow learning curve. Um, However, it's not just for beginners because the sophistication of the tools can grow as your needs does. So this is the example that we're going to show in the demo. We're going to be modeling flight sensor data. We have an Excel file with data from 13 sensors from one flight, one aircraft, uh, from Halifax in Canada to Detroit. And we're going to visualize, process, and then build our machine learning model based on the data that we have. So let's move to MATLAB. This is the MATLAB environment. We're going to use LiveScript. We're going to build a LiveScript, which is a tool in MATLAB to improve the readability of your code in case you are working in a team. You can write code, you can write text. We're going to build one now, and you're going to see the different options you have. You can also add LaTeX equations. You can add hyperlinks, images, GIFs. All of these will create a full written report of your code that you can share with your team members or with non-MATLAB users, non-programmers, or even for your future self. If you want to go back to a code that you have written a long time ago, this will be useful. So let's start by using the formatted text to, you also can divide the report, the live script into sections. So it will also help with organizing your code. So let's start with importing the data. Importing data is the first step in many workflows. You want to get the data into MATLAB to start working on it. Now, the data, we have it here, as you can see, flight data, and we in an Excel file. To import it, we're going to use import data. If we go to the Home tab, click Import Data, choose our data. This will open an import tool. As you can see, this is one of the low-code tools we're going to show today. It will show you a preview of your data. Here are the variables you have in the table, and you can see the rows. This is the time series data because each entry has a timestamp. You can choose which portion of your data you would like to include. Let's exclude the weight on wheels because it will not contribute to our machine learning model. So it's safe to exclude. And the output type, you can choose how do you want to import your data as a table, which we will do now, or you can choose some other data types that are available in MATLAB, uh, numeric matrix, string array. Another important section in the import tool is the unimportable cells. Some cells will be unimportable for various reasons. In the case of table, it's the empty cells because tables in MATLAB will allow you to have mixed data types. You can see that we have a number here, And here we have date time, which is another data type in MATLAB, and we are allowed to have it. But if we choose a numeric matrix, which will only allow numbers, you can see that date time will be marked as an unimportable cell. But we'll import it as a table. And we can choose what to do with these unimportable cells: replace, exclude rows and columns. We will replace them, unimportable cells, with nonce. Nonce, which is not a number, it's an object in MATLAB. It's useful to replace with none because you can look for none, you can remove nonce with special functions in MATLAB. So it's good to have any unimportable cell as none. You can choose to replace with some other value of your choice, 0 for example, or any other value, but we'll stick to none, not a number. Now you can just click here and it will be imported into our workspace, which will contain all the objects defined that you define in your MATLAB session or in your code, along with the value. In case we have a multi-dimensional data type like a table, it will show the dimensions of that table. But there's a more robust way to import data, is to create a function that is available in the import tool. If we click generate a function, it will automatically create a function for you that imports the data from that data file, along with a short description on the function of that function and an example that shows importing data from the file you have, flight data. You can see the name of the function is import file. Of course, to use the function, we have to save it. The name of the file must match the name of the function. That will automatically be set. And now we can use the function. We can copy the example and paste it in our code. Okay, let's run the section. Okay, let's first delete the one we imported before to see that it is actually importing the data. Of course, you can see the output inside your live script, but we can change the view to have a better view on, yes, the output showing under the code will be better. Now let's go back to the live script and let's run the code again. We have the flight data again in our workspace. Now the first thing we will do with our data is visualizing our data. It's usually a good step to do after importing your data to get to know more about the dynamics of your data and your variables. How do they go with each other? So we're going to start a new section and let's add a text saying we will plotting or visualizing. Let's go back to code. Now we have something called the live tasks. As you can see here, you can click on task. They are like mini apps that can be incorporated in your live script. They have tasks for different fields and workflows from data science, mathematics, signal processing, control systems. That they will do, usually they will automate a recurring or a typical task in a certain workflow. It will be automated by a live task. Now what we want, you can even import data with a live task, but we want to create a plot of our data. So create a plot, you can see this live task, it's added to our live script. You can see the various types of graphs that you can choose from, 2D and 3D. But we will just choose the regular plot. Then we have to select the data that we want to plot. The x-axis and the y-axis. Of course, flight data will be captured. Any variable or data set in your workspace will be captured immediately. And in case this data is a table, even the variable names will be captured immediately. So you can choose from them. Let's choose to put time, the independent variable, on the x-axis, and let's see fuel quantity on the y-axis. You can see that it's plotted immediately. You can see that fuel quantity is starting at a certain level and then declining over the path of the flight. That's expected from the fuel quantity of an aircraft. If you choose to show the code that creates this, you can click on show the code. Now this is anything but a static image. If you click on it, you can see that you can edit the X label, Y label, or other elements of the graph. You can edit them. and any editing that you do will reflect on your code. So you don't have to write the code to do that. You can even zoom in on a specific portion of the graph. And you can see MATLAB, even when we do some changes, MATLAB will automatically give me the option to update my code to reflect the changes that I have made in the graph. I can choose to move it around and numbers will change here. We can go back to the original view by clicking on the restore view icon, and we are back. Now, we want to visualize other variables because there are some artifacts, anomalies in our data, in the oil pressure as well as in the oil temperature of the aircraft. You can see that these dropouts will affect actually our machine learning model. So we want to get rid of them. This is common for sensors. When you're getting data from a sensor, sensors have sometimes this dropouts in the readings. So we will deal with that. Also, our response variable that we are going to predict in the machine learning model is the true airspeed, which is simply the speed of the aircraft. If we see here, we can see that we have few zeros in the beginning of the true airspeed data. That's normal because the aircraft will start at stationary and then it will take off. So it's normal to have the airspeed as zeros, but also that might affect our machine learning model. So we don't want that. So we will also deal with that quickly. We will also plot the longitude versus the latitude position of the aircraft, but you can see that plotting these on a blank graph on a white background will not be very meaningful. So we can use a different type of plot. The geo family of the plot, you can see them. We will use a geoplot, and you can see that we will immediately have a more meaningful representation of the data of the position of the aircraft. You can see it's going from Halifax, Canada to Detroit. Of course, you can see that the longitude is going to 0. Removing the true airspeed values in the beginning, the zeros will deal with that. We will see that it will fix that issue and we will have even a better representation. So let's go. Some cleaning data, we will do some advanced steps of cleaning the data, but we can do some very fast cleaning here from the table itself that we imported. You can see how interactive it is. It's not just images or data imported. Each variable will have a drop-down menu that if we go to the true airspeed, you can see the zeros. Click on it. You can sort the data from largest to smallest. It will also show you the limits of your data. We can see that the true airspeed will start from 0 and go to 438, the maximum value. Let's choose to, okay, first let's run this section again, just in case. Yep, and let's choose the value of 10. That's an arbitrary number that I chose. We will see how we can refine that number. Of course, we don't have any missing data, nans, not in numbers, but even if we do, we don't want to include them. So let's remove that. And you can see MATLAB gave me the option to automatically update my code to reflect the changes that I have made. Update code. We can add a semicolon to show only the output, because if you don't add a semicolon, it will show the output of the code. If we add a semicolon, it will only show the output of this part of the code. And we can run it again. And we can see that few data was excluded. If we run the plotting section again, you can see that the longitude, it solved our longitude problem by excluding the first few values of the true airspeed. Now if you see the code, here's the code, it's using the geoplot function. If you want to get rid of the controls to share your code or for some other reason, you can click on the options of the live task and choose to, you can show just the code only, like hide the controls, or if you want, you can convert the whole live task to code, which you can edit. And we want to do that because we want to, for example, change or modify some of the options of this graph. but we need to know the options that this function geoplot offers us. We can right-click on it and go to help on geoplot. MATLAB, one of the strong points of MATLAB is that it's a heavily documented function programming language. You can see that almost all the tools and functions in MATLAB are documented. They have similar documentation page, the title, the name of the function, possible syntax, description of possible syntax, and some examples, which are very useful that you can open in LiveScript and start playing with and exploring it further. Now you can see if we click on the name value pairs for this function, the options we have, we can change the color, the line color, the line style, and the line width. And we're gonna do a few of that. Let's, for example, edit our code. If I just write line, it will autocomplete my choice to and offer me some options that I can choose from. I will choose line width and set it at 2. It will also autocomplete. It predicted that I will change the color. So let's do that, and let's set it to red. And let's run the section again. You can see the changes that we have made have already shown in our graph. We also saw in the documentation, of course, the documentation can be downloaded like I have done here on your machine. So if you want to use your MATLAB on your machine offline, you can have the documentation downloaded. If not, you can access them through MathWorks website. But you can see that the maps here are more colorful. It's because they are using this option, geo-based map. They are using a topographic map. There are some other options that can be used. We can just copy this code and paste it here and run again, and you'll see that our map became more colorful and easy to look at. Now about the arbitrary number that I chose, I'm not sure how many readings that I want to exclude from our data, but I want to experiment with that. Now, instead of deleting this number, editing it, and then running the section again, I can use control. Controls are few like mini tools that can be added to your live script. And we're gonna add a numeric slider. You have these other tools based on your needs. Let's add a numeric slider. Let's delete that then. If we double click on it, it will show us the options to the slider. We can choose the minimum and maximum values. We'll choose from 0, say 500, and we want to increase in steps of 10. And it will run, the code will run when you change the value, run on value changing. And you can choose what to run when the value changes. Let's choose all sections because we want to visualize the effect on our plot when we change the value. Let's increase it to a ridiculously high number. You can see that we're only left with a few portion of the graph when we increase it, but we don't want that. So let's get it back to a reasonable number, let's say 120. You can see that this is more reasonable. Yeah, this is Halifax and this is Detroit. So now we have done a good job on visualizing our data. So let's start by dealing with the artifacts that we saw in the oil pressure and the oil sensor. We need to clean that. So let's start a new section, add another heading. Let's call it data cleaning. Let's go back to code. Another tool that we can use, like the import tool, is the clean data or the data cleaner. When you click there, it will open the data cleaner for you. You can import the table from Workspace because we have already imported it, or you can import from a file on your machine. Select flight data. You can see that it imported all the variables along with some statistics on each variable, on each data set. You can choose also to visualize the variables. You can choose what variables you want to visualize. Here are our oil pressure and oil temperature. Let's keep them the only ones on because that's what we want to do. And you can see also the statistical information on the data, like the mean, minimum, maximum, mean, and median. Of course, the cleaning methods, what do we want to do? from the dropouts in the sensor readings are outliers. They are considered as outliers. So we want to clean the outlier data. Of course, if you have missing data, you can do that. If you want to normalize your data, if you have a time series data and you want to resample the data, you can do that. Retime a timetable. Timetable is another data type in MATLAB, special for time series data. But we're not doing that now. So we're gonna clean the outlier data. Here we're gonna set the cleaning parameters. First, let's choose our variables that we want to clean, the oil pressure and the oil temperature. They will automatically show here. And we're gonna specify the cleaning method. We want to fill the outliers, we don't want to remove them. The fill method, what to fill our outliers with is you have to choose one of the algorithms to fill your outliers. For example, you can fill it with the next value. Wherever the outlier is, you can fill it with the next value, nearest value. Now, different algorithms will work differently with different data set. For this data set, I have tested that modified Akima will work best with that. The detection method is also an important option because it will tell your data cleaner that I want to, what do you want to be considered as an outlier? So we'll keep it as moving median with a threshold factor of 3. The moving window, since we have a moving median, so we'll have a window that is moving. It will be centered. Let's increase the window length because we have a huge data set. And you can see that the changes that we made will automatically be previewed here. Let's try to zoom in on a portion. Let's reduce the amount of visualization that we have here. Okay, so you can see here, now we want to see the outlier threshold. You can see the outlier threshold, the boundaries beyond which any readings will not be included in the clean data. Now to apply these changes, we can click accept and it will be applied. We have the original data and the clean data. Let's remove the original and we can see that our data is much better now and will suit our machine learning model that we're gonna build in a minute. Of course, the cleaning steps, you can have several cleaning steps for your data set and you can rearrange them by dragging and dropping, but we're gonna have just this one for this data set. We can export like we did with the importing, or we can also go down the robust path of generating another function that we can use with other data set as well if we want to perform similar cleaning processes to our different data sets. Generate a function and it will be automatically generated. We can rename that function. We can call it clean data. Of course, never forget to save the function with the same name. The file name matches the function name. You can see the fill outliers function is being used and with the options that we have specified in the data cleaner. We can copy the initiation of the function and paste it in our section here. Oh, sorry. Okay, now let's call it flight data clean to distinguish it from our flight data that we have imported. You can see that we have the clean data and we are ready to move forward with building our machine learning model. So let's start a new section. Let's call it model training. The code. And let's add another section to predict the response variable. I can call it prediction. Of course, I'm doing that fast. You can take more time to refine your live script to make it look better. So in the model training, let's go to the apps tab. You can see that MATLAB have a huge amount of built-in apps. These apps will also, like the live task, what will be more deeper and more complicated in the tasks they perform, also for different workflows in different fields like signal processing, control systems, and machine learning and deep learning. The one we are going to use is a regression learner because the state we are trying to predict is of a numeric value. You can also use the different amount of apps that we have here. Of course, also the app designer in MATLAB will allow you to develop your own apps. and I will say a few more words towards the end of the presentation about that, on how to build your own app for your special application. But let's use the regression learner now. Here's the regression learner. Let's import the data from the workspace because we already did that. You can set which data set you want to choose. Of course, we will choose our clean data that we cleaned. Then the response variable that we already established is going to be true airspeed, which is the speed of the aircraft. And here you can choose the predictors. What variables in the data set you want to use, you want your machine learning model to use to predict the response variable. Of course, you can choose what to include and what to exclude. We're gonna exclude the latitude and longitude because I believe they will contribute very little to the machine learning model predictions. And you can choose the validation scheme. You can set aside a test data set for testing your data. Now we're going to test with the same data. Again, we're going to feed it back to the model, but of course you can feed it new data to predict other states for other data sets. And we can click start session. Now for this, the default that you will find is the fine tree, decision tree model. You can choose to train it, or you can choose from the library of models that the regression learner app have. They vary from neural networks to Gaussian to linear regression models, or you can choose all quick to train, which we're going to choose now because we do not, because of the time constraint that we have. You can choose all. You can train all the models in the library if you want to see which model will work best for your data set. Or if you are following a model-based design workflow and you are using Simulink, and you want to use the machine learning model that you are developing here in Simulink, you can choose the all Simulink supported. Of course, some machine learning models will vary in complexity. So some of them will take a huge time to run. You will need to take that into consideration. So all quick to train. You can change the parameters at the PCA if you would like, but we will keep it as it is with the default selections. Now, the use parallel is also an important tool in MATLAB, in regression learner and in MATLAB in general. This will enable you to utilize the computational power, more computational power on your own machine, like multiple CPUs, or if you would like to scale that up to a compute cluster, you can also do that with MATLAB parallel server. Of course, you will need to use the parallel. You have to have the MATLAB parallel computing toolbox to use that. We will not need that because our data set is relatively small. If you have a huge data set or you have some special machine learning model that you would like to train to that is highly complex and will need high computational power, it's better to use the parallel. It will reduce hugely the computational time, but we don't have that right now. So let's start training the models that we chose. It will start training and showing you the RMSE value, the root mean square error. It's the difference between the predictions that the model made compared to the actual data. And you can see, for example, that the linear regression model performed poorly. However, the fine tree performed better than the linear regression. Now, a model that I have tested and know that it will perform better than all of these is the bag trees. You can change the parameters if you would like. But let's train it first before visualizing, of course. It's taking more time than the rest of them. And it's 0.57, which is better result than any of the other training models. So this is the model we are going to use. Of course, you can either click export as usual as we saw with the data cleaner and the import tool, and it will be in your workspace, or we can generate a function, which is the approach I prefer. So we can also, if we want to train the same model for other data sets, we can do that. So let's click on generate function, and it will be automatically generated with a description on what does this function do. And also it will give you an example on how to train the model and also instructions on how to use it to predict with your model. Let's save it as we did with the rest. Train a regression model. And let's copy this from the description and use it in our script. Let's pass our live data, the cleaned version, and let's train it. Of course, this function will have two outputs, a trained model object and the validation RMSE. If we go back here, we can see that the validation RMSE is the number we have, and the trained model is a special object in MATLAB of the type structure. Structure in MATLAB is a data type that will have fields in it. In those fields, you can store whatever you want. You can store a string. You can store some variables. You can see that we have an about field that will tell you about this trained model and how to predict field that will tell you how to use your trained model to do some predictions. And you can also pass function handles, which is the predict function field that we will use to predict. We can copy that from the instruction and use it here. And of course, it says here that replacing C with the name of the variable that is this struct, that is trained model. And again, we will pass our clean data. And then we will run it. You can see we have the predictions here for our response variable. That is the true airspeed. Now, let's go back to the slides. This is the MATLAB low-code tools that we have explored, the import tool, the easy plotting capabilities of MATLAB through the live task, the MATLAB apps, the regression learner app, it's an app inside MATLAB, and I will talk more about how you can build your own app. Also the live tasks that I have shown you. The data analysis workflow that we have followed in this demo is first, of course, accessing the data, whether it's a file like we have today, or a software, or if you are reading data from hardware, you can do that in MATLAB. The different amount of or types of processing that you can do to process your data. Also, the sharing, you can share your results in several ways. I will show one of them because we're going to share the report that we have created, and I'm going to show that in a minute. You can go even to outputs if you're designing actual system or deployment, and we will talk about that in a minute. So accessing data, regardless of where the location of your data is or the type of the data, MATLAB will have a variety of options to import data from and the types of data. Our data was a time series, of course, but anything can be a data, an image, a video, or a signal that you are reading from hardware. And the location of data as well is MATLAB provides a lot of options to access the data from. Now, the second step in the workflow of the data analysis, you can explore and discover your data. We did some visualization and we can consider to be done pre-processing because we cleaned the data, but you can also do some optimization. Also with a live task, it's very helpful. You can set up a full optimization problem and obtain results from that. Also in engineering, if you are control system engineer and signal processing, in the figure you can see the signal analyzer app. It's an app that will analyze your signal in time and frequency domain and will give you better insight on your signal, the one you are dealing with. And finally, artificial intelligence. In addition to the regression learner, we have the classification learner, and the one shown in the figure, the deep neural network designer that can be used. Also, it's a low-code tool. It will require low to no-code capabilities from your side and can be also used in quantization to get the network running on embedded hardware. Now, the share results with LiveScript, we have divided our code instructions. We haven't used hyperlinks, but you can do that. You can programmatically control fonts. We also did not use that. You can also use LaTeX equations if you are explaining that for teaching purposes. Let's go back to MATLAB. And if we want to export this live script, we can choose from one of the options here. We will export it to PDF just to take a look on how will it look after exporting it. You can see that the report it's created for us. It has the huge table, the data set we have, also the plot along with the code. Of course, you can choose to hide the code, or you can choose to hide whatever you want. You don't want to show this huge table. You can also edit it to make it the way you want. You can click here on hide code, and it will just show the outputs with the controls and any live task that you might have without the actual code if you're sharing it with someone, a non-MATLAB user, for example. Now, we are showing that MATLAB has a lot of low-code tools that require no programming, but MATLAB originally is a programming language, so you can use it and you can go as deep as you want. You can go from developing simple or complex functions to defining different classes, depends on the application you are using, and of course, the app design. You can also use that class definition for any complex application that you might have. It's not only just using the low-code tools that MATLAB already have, you can develop your own tools. Also, MATLAB projects and source control. MATLAB projects will help you if you're working in a team to keep track of large number of files. If you're working on a huge project, you can also use MATLAB to work with files under source control. You can perform actions like updating, committing code, or merge changes. We have a webinar on that in our YouTube channel. Please make sure to check that. It's called Project Management with MATLAB, Simulink, and GitHub. MATLAB is also integrable with other languages. For example, we have a live task that can, let me show you the live task. We can have a live task that creates, generate C++ interface and run Python code. You can generate a C++ library that you can call from inside MATLAB, or you can run a Python code. You can even call MATLAB from Python. So if you did some progress in C++, Python, or other languages, you don't have to redo the whole thing from scratch. You can continue with MATLAB, your application. For non-MATLAB user, we have several options that you can use. We have the MATLAB compiler, which will compile your MATLAB code to be deployed on different machines as a Docker container, Excel add-in, or MATLAB web app server. We have the MATLAB compiler SDK, the software development kit. It will turn your MATLAB code into C, C++ shared library, or a Microsoft.NET assembly, Java classes, Python packages, or Docker container-based microservices. Simulink compiler will enable you to share your Simulink simulations. If you are designing a system and you have a simulation and you want to create a standalone executable like an app, you can do that with Simulink compiler. You can also generate code from MATLAB code. If you have MATLAB code, but you need to deploy it into hardware, you can do that directly with MATLAB, but from your MATLAB code, a C or C++ code can be generated, an HDL, PLC, or CUDA. Of course, the MATLAB code compiled requires MATLAB runtime, which is a free to download software. You can download it on the machine that does not have MATLAB, and it will run any MATLAB app. Of course, for embedded hardware, you don't need MATLAB runtime because you will generate a fully functional C, C++ code, HDL, or PLC. We have also the MATLAB Central community. It's some resources that MathWorks provides, like a forum where MATLAB users can interact. For example, the MATLAB answers, where as a MATLAB user, you can ask or answer questions if you are stuck at some level in your application. You can also use file exchange, which MATLAB users, if they develop some functions, they can share it so other users can use it as well to save time. But not only functions, it can go from simple functions to full toolboxes that some users develop. We have some learning resources, the MATLAB on-ramps. They are short interactive courses that will take you probably 1 to 2 hours to finish, and it will get you up to speed quickly with MATLAB, Simulink, and the other fields. Of course, we have much more than that now, but these are just an example. This is the MATLAB on-ramp. This is what you will learn once you finish the course. And you can see in this figure that it is an interactive course. It's not just a video that you will see someone talking and explaining techniques in MATLAB. No, you will be coding with the person along with the tasks that will be on your left, and you will be verifying your solutions as well. If you will need more technical content, please visit our YouTube channel and make sure you subscribe if you want to see this webinar and many other webinars in the upcoming months. You can also follow our LinkedIn because there we promote and advertise the webinar, so you can register early. One of the few webinars that we have is the how to build an app from scratch. That's the one I was talking about early on. It will show you how to create or build an app for your own application. Also, we have the Signal Analyzer app webinar, the wavelet transform. We also have some licensing and installation videos. If you obtain your MATLAB license and you would like to know more on how to get going with your license. We also have our website, the cesimulations.com. We have some interesting content there, like the blog, where we share some articles on technical subjects and our activities.